Hey everyone, as we talked about at the end of last video, I'm going to be discussing some of the actual past, present, and future experiments that will be happening in space to mature the technology of optical communication, as well as share some detail regarding the design of these systems that might be helpful for your projects, and will answer some of the questions I've been getting emailed to me in office hours the past couple weeks. So to start, in 2014, there was the Optical Payload for Laser Comm Science, or OPALS, and it was launched to the space station on a SpaceX resupply mission and had been in development for about 5 years at that point. Now, at best, as we talked about in a prior video, the Mars Reconnaissance Orbiter can, when Mars is closest to Earth, at its very, very best, beam back data at about 5 megabits per second. Now, this experiment, which features the laser, gimbal, and the entire packaging that provides its power, as you can see on the left, the CAD model, got about 50 megabits per second down from the space station. Now, it's not nearly as far as Mars Reconnaissance Orbiter, but you can see that by going from RF to optical, orders of magnitude speed increases are attainable. And it didn't work half the time. I think they had 24 tests. And of those 24 tests, about 13, 14 were actually successfully able to beam down a short video from the space station. But this kind of was the very first test bed to show that laser-based communication from telescopes on the ground and objects in space is totally achievable and provides the increase in speed that was theoretically possible. And for your reference, for something like your projects, people have been asking me, this weighed about 160 kilograms, the entire package. And on one of them that I'll be talking about soon, I also have the power consumption. That's something people have been asking about. Now, forthcoming, launching between now and the end of the year, is going to be the Laser Communications Relay Demonstration, launching on Atlas V as part of a Space Force test bed project with some secret projects and this project from NASA. Now, the Laser Communications Relay Demonstration is going to be doing a similar thing as the Optical Payload for Laser Comm Science, as we just talked about, operating in low Earth orbit for however long, beaming back and forth data to mature the technology before it's used further out in space or by commercial operators. Now, theoretically, they plan to have this project produce downlink speeds of 1.2 gigabits per second. So now we're talking even orders of magnitude, that's 4 orders of magnitude beyond what was achievable in 2014 on the very first test bed. So with this technology maturing, it's possible to have, 6, 7 orders of magnitude more speed on the downlink than current RF solutions. One that actually just recently is getting ready to launch. I believe it's going to launch at the beginning of 2022. It's supposed to be around now, but got pushed back, is the Deep Space Optical Communications test bed. And this is launching as part of NASA and Lockheed Martin's Psyche experiment. And Psyche is going to do a Mars flyby and then investigate the asteroid Psyche for a couple of years, around 26, 27. And what this mission hopes to achieve is researching how planet cores are formed and how asteroids can carry bits of past planets or make new planets, planetary science investigation. The secondary objective with the Deep Space Optical Communications they're testing on it is having this laser communication technology we've been developing further out in space, because this is going to end up being beyond Mars, between Mars and the outer planets. And they theoretically believe they can achieve 250 megabits per second down on the ground. Now this, they got the size way down from the one that was launched to the space station as well. This entire package weighs less than 29 kilograms and continuously consumes less than 100 watts. So there's some possible benchmarks for you on your project in copying one of these systems to implement it in your communication strategy. And then at the end here, we're going to talk a little bit about how laser communication is being used between satellites in low Earth orbit, not necessarily satellite to ground, where there's no atmosphere and it's very easy for 2 satellites geostationary satellites like this one, the European Data Relay System, to know where each other are and orient themselves towards each other. Now, this system provides a continuous coverage across Europe and parts of the Eastern Hemisphere to have imaging satellites, communication satellites, military satellites operated by European countries that are on the other side of the world at the time, bounce back through these as a relay to get to the ground for you. And right now there's 2 satellites up providing coverage over Western Europe at geostationary orbits. And they, to have data go between the 2 of them, no longer use RF. They have a laser-based strategy as well, capable, because they're a lot closer and there's no atmosphere, mind you, of getting almost 2 gigabits per second between each other going down. Another similar use is by commercial operators. OneWeb, a satellite constellation currently in development, as well as SpaceX Starlink, shown here, are using optical communication between satellites to avoid having to use ground stations. Starlink specifically uses it for satellites operating near the North Pole at really high latitudes because they can't have ground stations there continuing to be operated. So this ensures these satellites from Starlink are not in geosynchronous orbit. They're constantly, as the end user, you're swapping between satellites all the time from your receiver at home. So these satellites use laser-based communication to provide a seamless handoff from one satellite to the next and lower latency. Once again, I'm available. We had a couple people come in with some questions regarding propulsion this past office hours, some questions regarding power consumption of things, and questions regarding the communications, as well as a few emails I've received and answered. So if you have any questions, you and your group has any concerns whatsoever, don't hesitate to shoot me an email or come by my office hours on Thursday. I'll hopefully do the research and be able to answer your question really quick. Take care.